Now that you are familiar with the schematic and all the control panels, let's put it all together. This section of the lesson demonstrates the electrical system using flight-related tasks. We will start with the schematic representing the unpowered airplane. Notice that when you enter the cockpit, the hot battery bus is powered from the battery. It's always powered either from the battery or from the battery charger, regardless of the availability of AC power or the position of any cockpit controls. Now read the DC voltmeter indication for the battery. Touch the correct selector. Because the battery charger is not powered, the DC voltmeter is indicating the voltage of the battery. The minimum acceptable battery voltage is 24 volts DC. Turn on the switch that will enable the battery bus to be powered. Touch the correct switch. The battery bus is powered by its alternate source, the hot battery bus, since TR3 is not powered. The lights which are on require only battery bus power. The bus off, transfer bus off, and standby power off lights will go off when the associated AC buses are powered. The generator off bus lights will go off when the corresponding generator breakers are closed. When the ground power available light comes on, the ground power tie bus and the external AC bus are powered. Now connect ground power to the airplane's electrical buses by turning the correct switch to on. Touch the correct switch. Powering generator bus 2 powers TR3, which allows the battery bus to receive power from its normal source, TR3, instead of from the hot battery. The bus off, transfer bus off, and standby power off lights go off because their associated AC buses are now powered. The DC meters are indicating the output of the battery charger, which is now powered. Observe the AC and DC meters as you perform the following task. The AC meter selector is already positioned to standby power. Do the same for the DC meter selector. Touch the DC meter selector. The AC and DC meters should have normal indications when the standby power switch is in the auto position. Remember that the DC amps meter reads 0 because it is not connected when the DC meter selector is positioned to standby power. Now move the standby power switch to the battery position. Touch the standby power switch. The AC and DC meters again have normal indications. However, the standby buses and the battery bus are now powered by their alternate power sources. The DC standby bus is powered from the battery bus. The AC standby bus is powered from the battery bus through the static inverter, and the battery bus is powered from the hot battery bus. Now move the standby power switch to the off position. Touch the standby power switch. The readings on the AC and DC meters indicate that the standby buses are not powered when the standby power switch is positioned to off, as does the standby power off light. Now move the standby power switch back to auto, its normal position. Touch the standby power switch. When the standby power switch is in the auto position, the standby buses return to their normal power sources and the meters to their normal readings. The APU has just reached normal operating speed. Now power generator bus 1 with APU power. Touch the correct switch. Now power generator bus 2 with APU power. Touch the correct switch. The entire electrical system is now powered by the APU. Note that the APU generator off bus light goes out when either generator bus is powered by the APU. Ground power has now been disconnected and both engines have been started. Now, power generator bus 1 with power from generator 1. Touch the correct switch. Now power generator bus 2 with power from generator 2. Touch the correct switch. Both engine generators and the APU generator are now operating. Note that each generator off bus light went out as its respective generator went online. Assume that the APU has now been turned off. The schematic which you now see represents the electrical system during normal cruise flight, and it will remain in this configuration unless some abnormal condition occurs.